Does Newton support Tron? What do you get when you combine the timeless principles of Isaac Newton with the cutting-edge technology of Tron? The answer is a fascinating exploration of how these two seemingly disparate fields can actually work together to create something truly remarkable. In this video, we'll be taking a look at how Newton's laws of motion can be applied to the world of Tron, a virtual reality universe where users can interact with each other and their environment in a unique and immersive way. We'll also explore how Tron's technology can be used to illustrate and explain Newton's laws in a new and exciting way. Section 1. Newton's Laws of Motion. Before we can understand how Newton's laws apply to Tron, we need to first have a basic understanding of the laws themselves. Here's a quick overview. Newton's first law of motion: an object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion will remain in motion at a constant velocity unless acted upon by an unbalanced force. Newton's second law of motion: the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to its mass. Newton's third law of motion: for every action, there is an equal and opposite reaction. Section 2. Applying Newton's laws to Tron. Now that we have a good grasp of Newton's laws, let's see how they can be applied to the world of Tron. Here are a few examples. Inertial motion. In Tron, objects continue to move in a straight line at a constant velocity unless acted upon by an unbalanced force. This is because the virtual environment of Tron is designed to mimic the real world in many ways, including the laws of physics. Acceleration. In Tron, users can accelerate their avatars by using their light cycles. This is an example of Newton's second law of motion in action. The more force that a user applies to their light cycle, the greater its acceleration will be. Action-reaction. In Tron, when two objects collide, they exert equal and opposite forces on each other. This is an example of Newton's third law of motion in action. Section 3. Using Tron to illustrate Newton's laws. In addition to applying Newton's laws to Tron, we can also use Tron's technology to illustrate and explain these laws in a new and exciting way. Here are a few examples. Visualizations. Tron's visually stunning graphics can be used to create clear and engaging visualizations of Newton's laws. For example, we can use Tron's light cycles to demonstrate the concept of inertia by showing how they continue to move in a straight line at a constant velocity until acted upon by an unbalanced force. Simulations. Tron's virtual environment can be used to create realistic simulations of various physical scenarios. For example, we can use Tron to simulate the motion of a projectile, and then use the simulation to analyze the trajectory of the projectile and identify the forces acting on it. Interactive experiences. Tron's immersive technology can be used to create interactive experiences that allow users to explore and understand Newton's laws in a hands-on way. For example, we can create a virtual lab where users can experiment with different forces and see how they affect the motion of objects. Section 4. The future of Newton and Tron. As both Newton's laws and Tron continue to evolve, it's exciting to think about the many new ways in which they can be used to educate and entertain. In the future, we may see even more innovative applications of these technologies as we continue to explore the intersection of science and art. In conclusion, Newton's laws of motion are just as relevant today as they were when they were first discovered over 300 years ago. And with the help of Tron's cutting-edge technology, we can now explore these laws in a new and exciting way. So, next time you're watching Tron, take a moment to appreciate the underlying science that makes it all possible. With that said, thanks for watching, and until next time.